Hi there, this is Srikanth Dasari. So in this lesson, we are going to focus on bitwise operators in Java. So first, let me launch the IDE. So we know that we are using NetBeans 8, which always takes a couple of seconds to load, since my system is very ancient. Okay, starting all the modules and gets loading. Okay. NetBeans. Okay. So first, let me create a new project here. So file new project. So let's say file new project, and let's take Java application, and let's name our project as so let's say bitwise operators, whatever you wanted. So whatever you wanted, you can say your project. Okay. So NetBeans takes the privilege of creating all the basic structure to our the basic.java file with all the comments and class and everything. I'm just adjusting the indentation so that it looks well. Okay. So the logical operators in Java are going to be like this. Okay. So they are bitwise operators. So bitwise and, bitwise or, bitwise negation, and apart from the bitwise bit manipulation, you also have bitwise shift operators. They are bitwise right shift, bitwise left shift, and bitwise. There is a new kind of operator which is specific to Java, which is this one, bitwise arithmetic right shift. It is also known as. Okay. So first, let us take two variables to demonstrate how this the bitwise operators work on our variables here. Okay. So bitwise operators are nothing but you have the opportunity to work on the lower level of the integer stored here. Okay. So lower level here means you can perform some Boolean operations, logical and Boolean operations using our bitwise operators on the binary equivalent of that decimal number here. Okay. So first, let us take two variables. Let's say a. Let's assign some value to keep it simple. I'm just taking two variables a and b, and both I'm assigning some values here, a to 1 and b to 2. And let's take a c also to store the result. Let's assign some dummy value to it. Let's make it 0. Okay. So the first operation is so bitwise and operation here. Okay, which is denoted by the symbol ampersand here. So first what we do is, let's say c is equal to, let's build an expression here, a and b. Okay, so this gives you the bitwise results get stored. The result of this bitwise operation between a and b gets stored in the c variable c. Okay, so let's output that using our system.out.println statement. System.out.println. Okay, so let's say a and b is equal to c. Okay, so if you run this application until here by pressing F6 or else this little triangle button, so you get the result. So the result, it says, is 0. So here we obtain the result 0 because so if you go back to your IDE, if you convert this a value, which is 1, a is equal to 1, that is represented in binary as 0001, and similarly we have b, which we have taken as assigned as 2, and its binary equivalent is 0010. Okay, so now if you perform this a and b operation on these two variables, you're getting 0. So that's because, so if you go back to Google once and revise once again the Boolean and operation. So Google is our friend to refer anything whenever you get any doubt here. Let's say Boolean and operation. So let's take, it has a truth table and some rules. Let's code images. Let's take this very first site here. Okay, so here the AND operation. So here this is the AND operation. I have entered into the site directly. Let's view the image full screen here. Okay, So this is the AND operation. It's a truth table of the AND operation. It's only true. Forget about this dot operator here. Okay, so you can use some notations. They use dot, they use cap symbol, they use ampersand, whatever they can use here. And here, so it is the AND operation, Boolean AND operation. It's only true. It's only the output is 1 if both both the operators or both the binary digits are 1 here. Okay, so rest of all cases it's 0. So if you come back to your IDE, now if you observe here in your operation, so here you have taken 1 and 2 for A and B values. So for each time, that condition never satisfies here. Okay, so that's never both the values which you have taken is both the values are 1, that occurs never here. Okay, so according to this AND truth table, it's only true when both the operations are true. Other all cases it's 0. So for that reason, our AND operation has yielded the result as 0. So run it once again. Here you're getting as 0. Okay. So in the same way, you can perform the OR operation also. So you can say A or B. Okay. So A or B. So again, in the same way, you can have this system.out.println statement if you run your application. So you get 3 here. Okay. So the reason because if you go back to your truth table once again for A or B, so it's denoted by plus here. So it's only false when both are false. In other all cases, it's true here. Okay. So if you go back to your IDE and if you in your program, so here you have taken A is equal to 1, that is represented as, let's keep it in comment here, that's represented as 0 0 0 0 1, and also you have taken B, which is represented as 0 0 1 0, and here you say A or B, so that is equal to according to your truth table, if you read right, it's only false when both are false here. Okay, it's only false when both are false. So in that case, it's false here, and rest of all cases it's true. So that is the ultimate decimal equivalent of that A or B operations result is 3. So for that reason, you're getting here when you're running the program, you're getting here as 3 here. Okay. So in the same way, you can perform the negation here. So negation operation, so that is simply you can say C is equal to negation of A. Okay. So again you can take the system.out.println and if you say directly, so negation of A, directly you can say, okay. So if you run your application, you get -2 here. Okay. So the reason you are getting a -2 here because so that is represented in the 2's complement representation here. Okay. So negative of n plus 1, negative of n plus 1. So internally that takes like this here. Okay. So that is represented as so negation of A, negation of 1 comes like this, minus of n plus 1. So again here n is 1. So in that binary representation, it's 0 0 0 1 plus 1 here. Okay. So that is equal to -2. So for that reason, you are getting here as -2. Okay. So you might not think that directly your bits needed to be inverted and you need to get some awkward results here. Okay. So internally the compiler takes this 1 in the negative negation form as 2's complement. So that is 1's complement plus 1 here. Okay. So the next operation is bitwise right shift. Let's perform that here. So let's say A right shift 2. Okay. So let's again take the system.out.println. I'm just copying and pasting it. Let's say so A. So right shifted twice. It's of A. So let's see what happens here. So run your program, you get here 0 because okay. So internally again the value of A, that is 1, that is binary representation is 0 0 1. So if you perform this operation, right shifting this operation on this one, so your bits get shifted right. Okay, 2 consecutive zeros gets added here. So ultimately that becomes this one, and that decimal equivalent of the 1 is thrown out, taken out as overflow, and it is ignored here. and your the executive zeros from the left hand side gets pushed, and your result is now 0. So for that reason you are getting here as 0. Okay. So next operation is left shift operation. So if you say C, and if you denote in the reverse way, and again if you take the help of the system.out.println, and here if you say something like this, okay. So if you observe on the program, you get 4 here. Okay. So that's because so again the equivalent of C, here we have taken A, which is 1, which is equivalent to 0001, and again if you perform A, this operation on that, so your 1 from the bits has to shift from the left hand side towards 2 decimal digits towards left hand side. Okay, starting on left hand side you need to shift your digits. So ultimately that is going to be like this, which is equivalent to decimal equivalent of this binary number is 4 here. Okay, so for that reason you are getting here as for the left shift operation you are getting here as 4. Okay. So the last operation here is so bitwise arithmetic right shift. That's going to be like this. Again you can take the help of this system.out.println, and you can just change this one. Okay, so you get 0. Okay, so the only difference between these arithmetic right shift and normal shift operation is that the consecutive zeros gets added in the at the end of the statement here. Okay, so that is the only difference. It's the new specific to Java. So this is specific to Java, so you don't find this arithmetic right shift in other programming languages. Okay, so this is the basic stuff about. Let's add a comment here. Bitwise operators. Okay, let's say them as bitwise shift operators. What are them? Bitwise shift operators here. Okay, so to summarize once again, we have seen the various bitwise operators in Java. So they are going to be like and, bitwise not, bitwise or. I made a silly mistake here. Bitwise or, bitwise negation, bitwise right shift, left shift, and bitwise arithmetic right shift here. Okay, so for each and everything we have taken a decimal. The compiler performs when it encounters the bitwise operator between the operands, it performs the operations on the binary equivalent of that decimal number, and then it gives out the result according to the Boolean logic if it's and, or negation. And if it's bitwise shift operators, according to the right shift or left shift, it manipulates the digits. Okay, so if you observe here, it manipulates digits from starting from according to the direction of the operator you are using. Whether it's right shift, it ignores the overflow and just shifts the bits here. Okay, whether it's right shift or left shift. So this is the basic stuff about so bitwise operators. You practice this code a couple of times, and you take a whole lot of you take the different values. Here I have taken just simple values here, so you can make it in different like negative numbers, or else in bigger higher decimal values. You can practice a lot. So see you in the next lesson. Goodbye.